Hey there, SolidWorks ninjas. All right, so this video is a sneak peek of our new SolidWorks 301 course, of course, where we're going to take everything that you've learned in the robot series, the remote control series, and build on that using a subwoofer series. Now, this is going to be a heavily surface-based tutorial, but of course, using a master model technique that's going to give us a lot of power and flexibility when putting together an entire assembly using mechanical components as well as design components. It's going to be a lot of fun. So stay tuned. Definitely head over to cadjunkie.com for full access to the entire library, or just check out this series directly. And yeah, we'll see you. Talk to you soon. Okay, now comes the really fun part. We get to actually start making some surfaces. And let's start with a really fun one. I'm going to grab the master model, open that up in its very own window. We don't need that speaker for the moment. And I'm just going to create on the right plane a new sketch. Make sure I'm looking normal to that sketch. And then grab my spline tool. I'm going to start something like right there. And then create a few points. Just something like so. And you don't have to be super, it doesn't matter if it looks right. You know, we're just going to get it close. Something like that. See, the inside of this is going to form a port, and I kind of want for that port to be all a part of this same continuous visual surface. But obviously that is one fugly curve. That is an ugly curve, and there's no bones about that. Right-click on it. Go down, first of all, and show curvature comb so we can see just how wonky this thing really is. And I'm going to set its density up pretty high, and then drag its scale down a little bit, because that's a little bit excessive there. Hit OK. And now we can at least see how wonky our curve is. And basically, if you're not used to reading a curvature comb, the curvature combs get longer based on how tight the radius is at a given point. So, tighter radius means more curvature or longer spine. Basically, it allows us to magnify the curvature of our curve, makes it a little easier to see what's going on. So I'm going to right-click this again and go down to Display Control Polygon, and that's just going to make it a little bit easier for us to control this curve just by moving these points around until we're happy with the overall shape of the curve. Now, this is kind of an eyeballing process, but that's just the way it is. Now, this is not, it's going to look very similar to making a NURBS curve in something like Alias or Rhino, but this is not a NURBS curve. And in fact, these handles are not real NURBS handles, okay? These are, it's an interpolated spline, and they are adding NURBS handles to it, or NURBS-like control handles to it, to make it feel familiar and controllable to people like you and me who are used to working in something like Rhino, even though in reality the spline is still a standard through-point engineering spline. I actually really hate that about this spline tool. I wish they would give us a normal NURBS spline, but there you have it. This is what we have in SolidWorks. Okay, so essentially this inner part is going to be, it's kind of shaped like a horn in a way. This is going to be the port coming out the back. And the reason we shape it that way is, well, to relax the air coming through so you don't hear port noise as the air flies in and out of there. Okay, so I'll exit that. And let's go ahead and just create a surface from this. We'll go to our Surfaces tab. We'll do a revolved surface. And we want to revolve it around that center axis. We only need to go 180 degrees. And if it's going the wrong way, you can flip the direction. But I do want it on this side. Hit OK. Now I have a surface. Now, the surface, when in its opaque form like that, is a little bit hard to read. So let's actually fix that before we jump back to our assembly.